Welcome to the Industrial Talk Podcast with Scott McKenzie. Scott is a passionate industry professional dedicated to transferring cutting-edge, industry-focused innovations and trends while highlighting the men and women who keep the world moving. So put on your hard hat, grab your work boots, and let's go.
All right, you industry heroes from all around the world, thank you very much for joining the Industrial Talk Podcast. You know this platform right here, as I point to it in the video. It's all about you. It's all dedicated to you. You are bold. You are brave. You dare greatly. You innovate. And you're changing the world as we speak as well as lives. That's why we celebrate you on this particular podcast, because you deserve it. All right, in the hot seat, we got a gentleman by the name of Andrew Schutte. All right. He is definitely a person who is with a company called Smooth Logics. He is the general manager, and we're going to be talking a little bit about bill of materials, BOMs. And you're saying to yourself, Scott, that's not sexy. Oh, it's dead sexy. So don't argue with me, because we're here to celebrate. Before we get into the interview, just let's take care of some business. All right. You know that this platform, the Industrial Talk platform, is all about the education. It's all about collaboration. It's all about innovation. And it's imperative that you hear that and you take action. Because without innovation, you're not moving that proverbial ball forward, right? And it starts with education, and it starts with the ability to be able to collaborate with great people out there. And what's really spectacular, especially on the Industrial Talk podcast, we have great people that are absolutely have a big desire to collaborate with you. Nope, they do. They want to collaborate. They want to educate. They want to innovate with you. Because right now, I don't even know what we call this time we live in, the squiffy pandemic, whatever it is. All I know, one, is that we don't have all the answers, and we're looking for answers, and we've got to be able to survive, rebuild, and prosper, whatever that future looks like. And to do that, you have to educate. You've got to collaborate with great industry professionals and innovate, not just from a technology perspective, but innovate on how you interact with your market, interact with your team, and really create some high-performance solutions. The next business, because I talk all about that, because it is all about that education, collaboration and innovation. I want to be able to highlight an organization at the University of Wisconsin-Milwaukee, Connected Systems Institute. That's an S on that, systems. And they're training that workforce of the future, that digital transformation workforce of the future. They've got an incredible team. Mary Bunzel, the executive director at the Connected Systems Institute, has just put together a rock star team to be able to develop the education that is needed for this incredible training of this digital world we live in. We need to do that. Manufacturing depends on that. Okay, I've covered all my business that you need to be aware of. All right, how are you doing, Andrew? Welcome to the Industrial Talk podcast, my friend.
Thanks, it's a pleasure to be here.
Hey, did I get the last name right? Schutte?
You did, indeed.
All right, you listeners out there, you're going to say to yourself, Scott, how do you spell Schutte? Yeah, I had to phonetically lay it out, but it's Schutte.
That is correct.
Pronounced Schutte. All right. Okay, for the listeners out there, give us a little 411 on who you are, Andrew, and then we're going to start talking a little bit about the challenges with bill of materials.
Yeah, thanks for the intro. I was born and raised in West Michigan, Zeeland to be specific, not to be confused with the Netherlands, although a lot of people came from the Netherlands. And we're on the west side of Michigan, but west side of Michigan seems to be one of the manufacturing and automation machine capitals. We build a lot of parts for the automotive industry, office furniture, medical, and we ship a lot of equipment and product over to the east side of the state by Detroit. So I grew up, my father had a small machine shop and equipment building shop we predominantly did automotive or consumer goods. So before I had a driver's license, I was making chips, running a mill, lathe, welder, designing in SolidWorks, running CNCs, programming CNCs, wiring, and plumbing equipment, mostly to assemble automotive parts or office furniture.
See, that whole area, Michigan, Ohio, Indiana, Wisconsin, that whole area up there is just it's just rich in manufacturing, rich in crafts, and tremendous. The people up there are so proud of what they can accomplish and what they build. There's a lot of energy in building. I love it. I love that passion.
Yeah,
now,
absolutely. We have a really good school support for it too. The local public schools, tech centers. I run a educational department at a local adult technical training school, and there's a lot of company support for the training in the school systems so that we have the next generations that are able to continue to weld and machine and design and make great things.
It's huge. Don't get me wrong. I think that there's other countries around the world. They're investing a lot of time, energy, and the old money into developing that workforce of the future. And I've been very impressed with that commitment to education, that trade education, and it's it's not like for me, it's not like my dad's view of what we did. It's pretty sophisticated stuff. There's a lot of real incredible innovation that exists today, and it's only getting better. And it requires some really sharp individuals to be able to, build. We need them. We just do.
Yep.
Just need them in a big way, and you need to educate them. You can't just throw them on the floor and just say, "Good luck, have a good time, figure it out." Nope. This is sophisticated stuff. Now, give us a little background on the company that you represent.
Yeah, so Smooth Logics was created by our need to solve an ERP problem in the industry. I was a automations design engineer for many years and still do a little bit from time to time. And one of the great challenges with designing a machine to put something together, we'll use the quintessential, like a door handle or a review mirror or something like that. West Michigan is famous for making those. And as an engineer, I would get a new door handle or a new review mirror for a new vehicle that I've never seen before in my life, right? 2023 model of the Chevy Suburban, for example. Right. And I then have to design a machine that's going to put together anywhere from maybe 6 to 25 parts. And usually the cycle times are, 5 to 6 seconds. So it might be a palletized conveyor line. It could be a rotary index dial. It could be any number of things. But every 5 or 6 seconds, we need to assemble, let's say, a Chevy door handle or a Ford F-150 door handle or whatever it might be.
Jeez.
And I mean, in these days, the same door handle fits on multiple platforms. So it's, probably Chevy Suburban, Tahoe, Yukon, etc., Silverado, whatever it might be. But one of the last large machines I did for the automotive industry, we're assembling F-150 door handles every 5 seconds. And it was...
I can't even wrap my mind around that.
Yep, it was 5.
I just can't. I'm sorry. I just like... That is innovative. I just can't wrap my mind around it. That's just spectacular.
And I mean, the statistics, as best I can remember, and this was about a decade ago, but it was every 5.5 seconds. The most complex version had 36 parts in it, because between the grip, the pin, the spring, the shock, the dampeners, the bezel, the back frame, the keyhole, the keypad, the retaining pins and springs to hold everything together. And it was all lean manufacturing, so we could do a red door handle for the front right of a 4-door, and then a green door handle for the back left of a 4-door, and then we could have a right driver's side door handle with a keyhole, without a keypad. Any combination, totally lean, quality checks along the way, and then the robots would palletize them accordingly so that the last pallet going on the semi was the first one coming off, and it would go right on the final production of the door panel assembly or the line assembly at the Ford plant.
See, I'm just telling you right now, if that doesn't get your skin a little tingly, because you've recognized that it's through the ability to be able to collaborate with these like companies like yours to be able to do this. It's just and the simple fact that you're creating these things and you realize the economy and the auto industry, if you're creating doors at five, my ear's bleeding.
Yeah, and
that's what happened.
And I mean, it's really amazing. We're kind of the tail on the end of the dog, right? We're taking 50 some parts, not counting colors, uniquenesses, and that kind of thing, and we're just simply assembling them. We're not even manufacturing the components themselves. They come to us. So we take a spring, we take a piece of plastic, we paint, we take a keyhole or a lock cylinder or something, and we're just putting them together and assembling it. There's an entire production line before that even manufactures and delivers and ships the product.
Yeah, see.
So getting down to the bills of material, right? Imagine as a mechanical engineer, you're responsible for designing a machine that has, I'll take a guess, I don't know that I ever counted, but 70, 80,000 unique components. Right, I'm designing a machine for a part I've never seen before. So I design a nest I've never seen before. I design hard tooling, robot end of arm tooling. There was presses, there were glue dispensers, there was everything, and it's basically all custom. Certainly you purchase some things, an ABB robot, for example. You can purchase some 80/20 and kind of do the erector set framing and guarding. But we had, we had plates that were torching out, machining down, lots of fixtures, lots of hard tooling. And all of that has never been designed because it's for an assembly machine that's never been built. That's for a part that's never before been, designed or made. And so the great challenge when I was a full-time design engineer, my boss would come to me and say, to meet deadline, or the shop is slow, or we got to get a jump on this, you, designer, give me parts so that the shop can make them. And from a designer standpoint, my response is always, well, the design's not done. And my boss is like, well, we need something to do, so give them this frame, give them this base plate. Like, is that part going to change? So then as a designer, actively designing a machine, I have to keep track of what's on order, what's on the shop floor, what has the 10-week lead time that already had to start being made or even bought, right? Robots have 10, 12-week lead time sometimes. So we might have bought the robot. So now I can't change the design too much lest the robot not fit or not work. So there's a very, very complex bill of material management problem, not only in the design itself, right? How many 12 millimeter proxies do I need to sense the 17 functions on this machine in various sub-assemblies and various quantities? But so there's a very complex bill of material management challenge, but it gets infinitely more complicated when you are incrementally ordering and designing, right? If I've ordered the frame, then I have a bill of material that has the frame on order, but then the bill of material changes. So now I have two bill of materials that don't match. The bill of material from last week when I ordered the frame and other parts, and the bill of material from this week that doesn't match. So I have to match those up. And then I have to carry over what was ordered and what wasn't, and then I have to order more or cancel some or replace some or increase quantities or decrease quantities.
And I have to interrupt here because this is all with this particular line. This analogy, this example is of you designing something new to be able to deliver a product at the end and be able to do it efficiently, meeting whatever time specifications, quality specifications, and it probably becomes your flexibility to be able to manipulate that line becomes less flexible as you progress down that road and to be able to.
And I'm also, on that particular project, that F-150 door handle project, I was also working with 4 other designers. So
Right. You have the other human element.
Right. I mean, a different designer could change something that affects my components or my bill of material without me knowing about it, and then what gets ordered doesn't fit. So, I mean, there's always reworks, there's always, that part no longer fits, I forgot to change something, or I changed something and forgot to document it, or I documented and forgot to tell somebody, or I told somebody but it was already made. And one of the great challenges of custom automation or custom anything, machine building, automation or otherwise, is at the end of the day, when you start bolting it together, figuring out what parts you don't need that got ordered, what parts you do need that didn't get ordered, what parts that did get ordered that were wrong or changed, and what doesn't bolt together. I mean, I've been in this industry my entire life. I've done it since, like I said before, I had a driver's license. And at the very end of the assembly, do we have the parts? Where are they? Are they correct? And do they bolt together? Is, always 2 or 3 weeks before the machine is supposed to be done. And it's all hands on deck. It's a total scramble. It's absolutely insane, depending on the size of the project and how well it's managed, if you don't have good bill of material management and integration.
So with that said, what are the solutions, man? My tuchus is already tight listening to you and all the challenges that exist associated with pulling this together and getting the right BOM out there. What are the steps, man? Give us some actions here.
Yeah, absolutely. So from a designer standpoint, engineers are known for being meticulous and very precise and accurate in their trade, and those are all really good qualities. When I look back, a quick sidebar here, just a minute, because it's a fun stat.
Yeah.
But when I look back at the mistakes I made as a mechanical design engineer when I was in industry full time, most of the mistakes that I made were in managing paperwork, right? Like 4th grade math between bills of material and trying to match up quantities and match up bill of material line items. Most of the mistakes I made were clinical paper processing bookwork issues. My designs were and have historically always been very good and very accurate. It's just a matter of, are you properly communicating, documenting, and managing from a bookwork standpoint the design that you have in CAD. And so much of the industry is absolutely backwards. I would have to print off stuff that I wanted to have made and take screenshots of bills of material to give to purchasing and say, buy these things, and give physical paper prints to the shop floor and say, manufacture this component, right? You've never seen this block with a hole in it before. Can you make me 3 of them? So where Counterpart really shines, Counterpart is our ERP solution, counterpart-erp.com, is we directly integrate with SolidWorks. So
you got to explain SolidWorks. That's fine, but what's SolidWorks?
SolidWorks is probably the most prolific 3D CAD software in the world. Last I knew, they have more licenses and more users out there. It's the software that I teach at our local adult education trade school for mechanical design. And it's a product from Dassault Systems. A sister product would be like CATIA or X-Design is a newer variant. But they're an OEM CAD design software, and it's pretty much the #1 CAD software in the particular industry that I'm referring to as the automation machine build industry.
Got it.
So we directly integrate with SolidWorks, which is really exciting because I can design anything I want in SolidWorks. And from inside of SolidWorks, never leaving the CAD program, which as an engineer, right, that's all I ever want to look at. I don't really like looking at my email. Other than emails from you, those are pretty sweet.
Right. Well, thank you very much. I appreciate that.
But as an engineer, right, I want to look at CAD. I want to design. I want to be creative and stretch my abilities and my thinking in what I am good at and what I'm passionate about. The rest of it is just a necessary evil. So Counterpart allows the engineers to stay inside of CAD, stay inside of SolidWorks, and from inside of SolidWorks, create an order request and say, I, the engineer, I need one of these frames made, and then keep designing. I never have to print paper. I never have to talk to another person, which is usually a plus in the engineering world. We're not very people-friendly. And then as I keep designing, I can continue to order, modify that order. If I change the frame, I can process a revision. And all of that electronically gets communicated in real time downstream to purchasing, to manufacturing, to assembly, to everybody else. So it really eliminates mistakes. We've had customers gain 15 to 20% of engineering efficiency and reduce mistakes, and not design mistakes, right? If I design the wrong hole, I'm going to get a wrong part. But the accuracy conversion from CAD, from SolidWorks, down to the shop floor, we've reached high 90th percentile of accuracy using the software correctly, and the mistakes have been human error. So it's a really amazing tool. It drives a lot of innovation and efficiency in communication, going mostly paperless. Because if I have brilliant 3D CAD on computer, why would I reduce that information to a physical paper print to give to a machinist, a CNC machinist, who's then going to go get the 3D CAD and machine off the 3D CAD, right? The paper doesn't really help much anymore in today's society, especially with the proliferation of 3D printing and everything else.
Right. See, this is interesting because you've created a platform, a system, a process that instills a level of discipline, and you're absolutely spot on. If I have to go from system to system to system to system and all of this around and everything in between, there's challenges with that,
right.
No doubt about it. I get it. But what you're just saying, SolidWorks, boom, I'm there.
Yep. Like one of the biggest competitors that we have in our space, I would say most of the companies that we sell to, their previous product process was require the engineer to log into QuickBooks and create a purchase order to buy the things that they need. Like that's most of what happens when we demo or when we are talking to a company, and the business owner is like, I'd really like it if I could get my 7 engineers, if I didn't have to require them to use QuickBooks every day. And you're like, that's just such the wrong tool for the application, right?
Oh, now you don't want them in there,
right?
You guys stay in your stay in your zone right there. Stay in that CAD program and get that thing done and allow technology to generate what is necessary to fulfill those orders and to make it happen.
Right.
Now, that's all great. That's all wonderful. But that there are roadblocks. Not everything is, pink elephants and, cotton candy. What are the challenges here?
I mean, so many of the challenges are discipline and rigor. Without having a direct SolidWorks integration, there's a little bit more flexibility, right? I can half design something and say, I know there's going to be a robot there, but I didn't put the robot in my design, just go order a robot. So it kind of raises the bar and it says what's in SolidWorks is what you're going to get. So make sure your SolidWorks models are accurate, update your SolidWorks data, and it's kind of a WYSIWYG product at that point. What you see is what you get. And it requires a little bit more rigor and discipline on the engineering side to make sure that all the I's are dotted and the T's are crossed, to make sure that you're going to get what you really want in the end.
But there are roadblocks. I mean, this sounds great. This sounds perfect. This sounds like the ideal. What's the why? What are the roadblocks?
Well,
why? Is it just people? Is it like, I've got my ERP here. I use this CAD and we do this and I have no problem over here.
Yeah,
I would imagine that's the case.
Most of our customers don't have ERP. A lot of the customers that we sell into, they're using QuickBooks or Excel. Of course, software.
Hey, you kidding me?
No.
It's not a slam on Excel. There's a purpose and reason
Excel
for Excel.
is amazing, but Excel is probably is the software we replace the most often.
Get out of freaking Dodge!
But understand, a lot of these small automation companies, it's an owner that's really good in SolidWorks or design, or a controls engineer, or somebody like that who started out designing and building with a 3-man team, where everybody communicates and you've got Excel, and then they grow into a 30, 40, 60 person company, and then pretty soon their old processes don't work.
It just overwhelms. It's like this, guys, like walking through probably quicksand. It would be tough. It would be tough, and you've just bite the bullet, make it happen. Hey, we're going to have to wrap it up. Here's the deal. What you were talking about resonates with me. How do I get a hold of you?
Counterpart-ERP.com is our product website, or you can email me or any of the sales team from the links at that domain.
So you don't have any issues with me providing your email address out on industrialtalk.com?
No, mine or the generic sales email address would get you connected to the right sales individual, or me directly is no problem at all.
Excellent. I like that. All right, listeners. You got to get a hold of this gentleman. Andrew Schutte is his name. Smooth Logics is the company. The other website is counterpart-ERP.com. And you know as well as I do, everything will be out at theindustrialtalk.com. So fear not. Do not worry about, hey, I want to get a hold of Andrew, but I don't know how. Just go to industrialtalk.com. Find his his podcast. Look for all of the contacts that are necessary. Andrew, thank you very much for joining the Industrial Talk podcast.
Thank you, Scott. I appreciate it. It was a real pleasure.
Excellent time. All right, listeners, I want you to be bold, brave, dare greatly. Hang out with people like Andrew who are bold, brave, and dare greatly. And I'm telling you right now, your view of the world will change and you will be a positive impact to changing lives. But that's what you do anyway. All right, we're going to be having another great interview like Andrew right around the corner. Thank you very much for joining. We will be back with another great interview shortly.
You're listening to the Industrial Talk Podcast Network.